know how to work with a linear equation in slope-intercept form. What's the slope-intercept form of a linear equation, everybody? Y mx plus b. And it has two things that you absolutely need to have. M and B. What's M? Slope. And what's B? Okay. And we've talked about it before. When we go to like a real life problem, yes, M is slope, but like in an actual application, how do we think of M? A rate of change, like miles per hour or something. And how do we think of B? The starting value, right? So linear models in this form, y equals mx plus b, yes, right? Have an m and a b. The slope, m, remember that is the rate of change in this, whatever the situation is. And the b is your initial value. Like whatever you happen to be starting with in the particular problem, okay? And so they describe it as slope tells us how fast the output changes relative to the input, right? Inputs are the x's, outputs are the y's. Tegan, get that thing off your wrist and put it over there, because that's not me. And the y-intercept b is our starting point, right? That's where the x is 0, right? But let's say we're using time, t, instead of x. Remember that paramecium one, right? They're growing and dividing. And the starting amount was at time of 0, okay? Or x of 0. So let's look at the first one here. So what does Janine have right now? You're all reading this with me. She has $450 in her savings account. When? At the beginning of the year. Does that sound maybe like an initial value?
Yeah.
Like if we were going to write it, we were thinking ahead maybe, what part of our equation would that 450 be?
Y-intercept.
Yeah. Wouldn't that be the initial, the y-intercept, right? But initial value or the b, right? Okay. And she puts money in the account, how often? Every week, $5. What does this sound like? The rate of change. What's changing?
$5.
Right? The amount of money in her savings account. And what's the rate at which it's changing? $5 every week. Okay, so that's our M. That's our slope. Yeah? Okay. And they want to model the amount of money she has in her savings. They're going to use S for the amount in the savings. And that would be the output, wouldn't it, of our function? As a function of what? Number of weeks, W. So that would be our what? Input. So we'll have an input, the number of weeks, and what will come out will be how much money she has. S, yeah? So let's just make our little table here. So number of weeks at week 0. And I believe we're going to be talking about full weeks here, okay? Not like partial weeks. Okay. Well, this is the starting amount, right? So basically it's $5 times 0 weeks plus what does she start with? $450. And so what is in her savings? $450, right? So next week, week 1, it's $5 she puts in, right? Times the number of weeks, which is 1, plus what? The $450. So how much does she have after week 1? $455. So we keep doing that. Now we're at, careful, it's not going to 2, it's going to what? So $5 times 5 weeks plus what she started with, right? Was 5 times 5. So how much does she have? $475. And then 10 weeks would be $5 times 10 of those weeks, plus the amount she started with. So that's 50, yeah, plus 450, which is $500 at the end of 10 weeks. Yeah? Okay. So part B, use information in the givens. That's a weird way to, I don't know what the heck. Or in the table to write an equation for savings, S, is a linear function of the week. So wouldn't it be like in this form, S equals MW plus B, instead of Y equals MX plus B? Right, just different, right? The output is S now. Okay, so what's the M in this case? Technically 5 over 1, right? And what's the B? 450. So what's the equation, everybody? 5 what? W plus 450. So there's our equation, our linear equation. Instead of M, or instead of X and Y, we're just W and S, yeah. Okay, so part C, if Ginny saves for exactly 1 year, what is the range? Oh, what is range? It's the Y values, right? And what's domain? Oh, right, but in this case, the S savings values, right? Well, like the lowest to the highest in the range for the Y's, what would be the lowest value she has? The lowest output is 450. And after 1 year, I guess we're going to have to figure out what the highest value is, right? So what do? Use that equation and put what in for?
5 times 12.
Hold on. So we're going to use S equals 5 times, it's 1 year. The W is the number of what? Weeks. What am I putting in there for the W? How many weeks in a year? How many weeks are in a year?
45? 40 something? 45? 48?
I don't know.
I have no idea. 282, that's more.
52. There's 52 weeks in a year.
I knew it was supposed to 282.
May I, do you know that now? There's 52 weeks in a year?
I didn't know that one. I didn't know that.
And now you do. And now, please, never forget that. There are 52 weeks in a year. Please don't let another human being ask that question and get that look on his face. We'll keep it between us.
Why did I be a head?
52 weeks in a year. So what goes in here? 52 plus 450. So what is in her savings after 1 year? How much money? 5 times 52 plus 450 is $710. All right, so what is the range from what to what for that year?
450 to 700.
Remember how to write that? That's 450 less than or equal to S, instead of Y, right? Less than or equal to 710. So that's her range of savings values for 1 year. You know, like what?
Doing like the less than equal to add plus than or equal to.
It's very difficult.
No, it's not. It's boring. All math is boring.
Time consuming. You got other things you got to take care of.
Yeah.
You're not getting to. I mean, a less than sign is time consuming. Right?
I get that mixed up with the grid.
How many weeks are in a year, kids?
51. 52.
Part D, why would it not make sense to evaluate for S of 6.5? We're dealing with whole weeks, right? Yeah?
Yeah.
In other words, what types of numbers belong in the domain, right? That's the inputs, okay? Well, how do you know we're only, because the problem says she deposits how often? Once a week, right? And it doesn't say anything about any in between, right? So she only deposits once per week. Only deposits once per week, nothing in between. Yeah? What about the domain? I should put an R up here for range, by the way, right? What about the domain, D? Well, they wanted to know it. For all time.
From 1 to 52.
1 week?
Do 0 weeks.
Oh, we started at 0 to what? No, who says she's stopping at a year? That was back in
Well, it
first.
never says that she goes on past a year.
Hmm?
It doesn't say she goes on past a year.
But it doesn't say. she-
Well, wouldn't we have to assume that unless it said otherwise?
So.
Why, I mean, what would stop her from saying after a year?
From losing her job.
We didn't say that.
Her dropping out of school and
So from 0 to what?
infinity.
Okay, could we just simply write that as the domain, we could write it, it's W, right? Greater than or equal to 0, right? Well, hold on. Wouldn't what I just wrote there, I mean, remember, that's the same as saying from 0 to infinity, right? It's implied in that, right? But doesn't that imply, the way I wrote that, there's no restriction that says there's no half weeks, the way I wrote it?
Half weeks. There are no half weeks.
I know, but the way I wrote it, like if you just saw that, would you know that?
Yeah.
This right here?
Yeah.
Why would you know that? Huh?
I don't.
She's only depositing once a week, so we're not gonna have, say, 6.5 weeks.
Because above it, it says she only deposits once per week.
How could I change this? Maybe I could put a comma and put one more little restriction on W. What kind of number will W have to be?
A whole number.
A whole number or an integer, right? W is, close together there, I'm just gonna look like whiz. Why does it do this to me? W is an integer. All right, so do you see how I put that? I had to put that little restriction on there so that you know you won't have a W of 2.7. It'll only be 0, 1, 2, 3 in this case. Okay, so that's your domain. All right, what do they want us to do in part E? There's a couple points to do what? Rate of change. In other words, they want us to verify the what? Slope. Or M. Do we have a formula for M?
M equals y2 minus y1 over x.
All right, so that implies we have 2 points, yeah? Well, let's find 2 points up there. How about 10 weeks and 1 week? Give me coordinates for week 10. Let's see. Input, comma, output. 10, comma, 500, yeah? And what about for 1 week? 450. No, it's not. That's the 455. Yeah. Okay. So now we're just going to do our slope on that. Everyone take a minute right now and put these into the slope formula. Geez, well, yeah. Okay, everybody at home, I forgot to record. There's our slope of the 2 points and all. Okay, because you all watch this. Yeah. All right, next page. You probably ought to. All right, what do we got? We got Kirk's driving.
How long?
Not Kirk. Kirk always drives. For some reason.
A name like Kirk, you're going to be in the driver's seat. So he's driving at a constant speed. Hey, that sounds like slow. Constant rate of change. Okay. Where's it? Which way is he driving towards?
Okay, so would it be like
He's driving which way?
towards
Towards Denver. So is he getting closer to Denver or farther from Denver?
closer?
Okay. So just before we even finish reading, the number of miles he is from Denver is getting larger or smaller?
Smaller.
Okay. So he knows that after 2 hours of driving, how far is he from Denver? So after 2 hours of driving, he's 272 miles. And then what?
After 3.5,
He's 176 from Denver. Does that sound like a pair of coordinates, a couple of sample X, Ys? I think they're going to ask us this here. Part A, summaries information given the problem is two ordered pairs. Yes, they do. So what would be the ordered pairs? Input of 2 hours, output of 272 miles. And what's the other input?
3.5 and 6.
And 176 miles as an output. Okay? Between what? Oh, I see, yes. All right, so H is the input. I guess H is the number of what? Hours, and capital D is the output, and that's what? Distance what? It'd be specific. From Denver, right? Okay. So now they want us to do the rate of change. Calculate, what's this say here? 1 over what? What does that say? What does this say? Delta D over delta H. Remember, that just means change in, difference in, right? Subtract. So we need to, what's here? So D of 3.5. What is D of 3.5? Look at your points here. 176 minus D of 2. What's D of 2? 272, yeah? So isn't this y basically y2 minus y1 over x2 minus x1? You mean the function notation? Remember, the function just replaces y, right? Like f of x is the same as y. But in this case, it's just d of h. So whatever.
D of that is just way more confusing than.
But now you can connect it by the fact that it's a function of time. And that's all it is. That just tells you the output. You know. So what is again? What is D of 3.5 equal?
176.
176. What does D of 2 equal? 272. So there's the numbers that go in there. You do what? No, you know that's not multiplying. That's function notation. Yeah. D of, right? Like f of x is not multiplying. It's notation. F is a function of x. This is D is a function of time. When time is 3.5 hours, etc. Okay. All right. So what are we going to put on top here? Over the inputs that made them happen. Right? We get what? Think of 96 miles to what? 1.5 hours. And let's put that as a unit rate. You'll have a calculator. Negative 64 what? What is it? Negative 64 what? Yeah, or m miles per hour, right? That's his rate of change. In other words, it's his speed, isn't it?
It's going negative 64?
Yeah, think about that. And I think that's why what they ask us in Part C. Look at Part C. What does it say? You should have found what? Rate of change is negative.
Because he's getting closer.
Right. So what did I ask you before? His distance to Denver is doing what as time goes on? It's getting closer, it's getting smaller, right? So wouldn't it make sense for the slope to be negative? The rate of change to be negative?
So then it goes into positive when you reach.
No.
It wouldn't have to be like negative 64, it could be like subtracting that.
Well, eventually, when he gets to Denver, the distance will be what from Denver? When he's in Denver, what's his distance from Denver?
0.
Oh, 0. So eventually this thing will be 0, won't it? Okay, so his distance is decreasing. That's why we answer this, right? His distance from Denver is decreasing because he's getting closer, right? Okay. All right, so part D B, I want us to assume the relationship is linear. Right? Makes sense if you keep your cruise control on, constant speed, right? Write an equation for the distance D as a function of H. So in other words, it'll look like this, but instead of X and Y, what are we going to use? Well, what replaces the X? H, the input, right? And what replaces the Y? The distance, yeah? Okay. So the only thing we don't have is a what? A B, right? What would be the B in this? What does that mean? What did I tell you B meant on the other page?
Starting point.
Okay, so in this case, what would it represent?
Negative started.
Okay,
It would be,
his what? Starting distance? Keep going. From Denver, right? Okay. Well, just like the last homework, do we have an M? What is our M? And by the way, let's write this as D equals what? M times H they're using? Yeah. Okay. So we have an M, which is negative 64. Do we have a sample H comma D?
yeah.
We do, don't we? We got two of them, don't we? 2 comma 272, and the other one is what? Let's use the 2 comma 272. Okay, so we're going to use this guy here. What do I replace the D with? 72 equals what? Negative 64 times 2 plus B. So let's find what B is. So 272 equals negative 128. Right? And what do we do now? Add 128 to both sides, and what do we get? For B.
400.
400. So he's starting out how far from Denver?
400 miles.
Okay. So what is the actual equation now that we have an M and a B?
So, y equals.
D.
Negative 64x.
Nope. We're using H
Plus 400.
plus 400. Okay. We're just doing the same thing we did in the last lesson, except we're using D and H. Okay. Well, it just says he starts 400 miles from Denver, and he's getting closer by 64 miles every hour. So.
Did we just show what number E?
Yeah, I kind of asked that already, right? Part E. How far did Kirk start from Denver, right? Yeah, well, let's think of it as at 0 hours of him traveling, right?
0.
At 0 hours, right? So D of 0 equals negative 64. Negative 64 times 0 plus 400, right?
Yeah.
So what does D of 0 equal?
400.
400 miles from Denver. See how I put a 0 in for the H? No hours have gone by. Starts up right from Denver. Okay?
Your thing is loud. It's a little funky.
All right, this part. For how many hours will Kirk arrive in Denver? So in other words, again, I'll ask you, when he arrives in Denver, what is his distance D? 0. So they're asking us basically, when do we get D equal to 0? So what do we do here? Oh, well, subtract, I have nothing to subtract and write it down. Do we have an equation with a D in it?
Plug in.
So we know that all this stuff is going to equal what? 0. So how about negative 60? God, I keep doing the 4 first. Weird. Negative 60. Oh, I don't know. Do here. 64H plus 400 equals 0. I just put the D on the other side. You know how I am, right? I don't like that variables on the right.
Subtract 400.
Now we're going back to Todd's Learning Center, right? So negative 64H equals negative 400, yeah? Divide both sides by negative 64. And how many hours does it take?
Probably 4.
Well, let's not do probably like. Let's get our calculator out. 6.25 hours. 6.25 hours. Okay? So there's nothing different than what we did on Friday, except now it's just in the context of the problem.
Wait, why would you put H equals?
D, yeah, because it's H. I solved for H, the number of hours. Because they wanted to know how long, right?
No, that's you repeat your hours.
H is a variable that represents a number of hours. Better pause this. All right, we got one more thing down here.
4 feet per second.
Sorry, Amanda, yes. You're reading it. Everyone read it. What's she doing? Walking where? Everybody.
Way.
How fast?
4 per second.
That looks like an M to me, right? And she starts what?
6 feet.
That looks like a what to me? A B, starting point. Which of the following gives her distance? So M equals what? 4, and B equals what? 6. So what would the equation be?
D equals 4C plus
Plus 6. What choice?
number 1.
It is in fact number 1. Okay? All right.